Today we're diving into the world of exception handling in C. Exceptions are unexpected problems that can occur while your program is running. Imagine trying to divide a number by zero or accessing an array element that doesn't exist. These are classic examples of exceptions. In C, exceptions provide a structured way to handle such errors, allowing your program to respond gracefully instead of crashing. Throughout this video, we'll explore what exceptions are, why they matter, and how you can use C's powerful tools to manage them effectively. Let's start by understanding the basics of what an exception really is. Exception is a problem that arises during the execution of a program. In C, exceptions are responses to exceptional circumstances, such as dividing by zero or referencing a null object. When an exception occurs, it interrupts the normal flow of your program and transfers control to special code designed to handle the problem. This mechanism helps prevent your application from crashing unexpectedly and allows you to provide meaningful feedback or recovery steps for users. Understanding exceptions is the first step to writing robust, error-resistant code. Zhash provides a clear and structured way to handle exceptions using the try, catch, and finally blocks. The basic syntax involves wrapping risky code inside a try block. If an exception occurs, control moves to the catch block where you can handle the error. The finally block, if present, always executes regardless of whether an exception was thrown. This structure ensures that your program can manage errors gracefully and perform necessary cleanup tasks, such as closing files or releasing resources. Try block is where you place code that might throw an exception. Only the code inside the try block is monitored for exceptions. For example, if you're performing a division operation that could potentially divide by zero, you'd put that code inside a try block. This way, if something goes wrong, the program can catch and handle the error instead of crashing. Think of the try block as a safety net for risky operations. Let's look at a simple example. Suppose you have a division operation, int result equals 10/0. Placing this inside a try block ensures that if a divide by zero exception occurs, your program won't crash. Instead, you can catch the exception and display a friendly message to the user. This approach keeps your application stable and user-friendly, even when unexpected errors occur. For the try block, the catch block is where you handle exceptions that may have been thrown. You can have multiple catch blocks to handle different types of exceptions, such as divide by zero exception or index out of range exception. The first catch block that matches the exception type will handle it. This allows you to provide specific responses for different error conditions, making your error handling precise and effective. Consider a scenario where you're accessing an array element that doesn't exist. You can use multiple catch blocks to handle different exceptions. For instance, catch index out of range exception handles out of range errors, while catch exception acts as a fallback for any other exceptions. This layered approach ensures that your program can respond appropriately to a variety of error conditions. Finally, block is used for cleanup tasks that must happen whether or not an exception was thrown. For example, if you open a file, you should always close it regardless of errors. The finally block ensures that essential cleanup operations like releasing resources or clearing memory are always performed. This helps prevent resource leaks and keeps your application running smoothly. Let's see the finally block in action. Imagine you perform a division operation inside a try block. Whether or not an exception occurs, the finally block will execute, allowing you to display a message or perform cleanup. This guarantees that important final steps are always completed, making your code more reliable and maintainable. Throw keyword is used to manually raise an exception in your code. This is useful when you want to signal that an error or invalid condition has occurred, such as an invalid user input. By using throw, you can create an exception object and pass it up the call stack where it can be caught and handled by a try-catch block. This gives you control over how and when exceptions are raised in your application. Suppose you have a rule that users must be at least 18 years old. You can check the age and use throw to raise an argument exception if the condition isn't met. This approach allows you to enforce business rules and ensure that your application only processes valid data. The thrown exception can then be caught and handled elsewhere in your code, maintaining a clean separation of concerns. Let's walk through a practical example. Imagine you're dividing two numbers, but the divisor is zero. By wrapping the operation in a try block and catching divide by zero exception, you can display a helpful error message instead of letting the program crash. The finally block ensures that a final message is always shown, regardless of the outcome. This pattern is essential for building user-friendly and robust applications. When a division by zero occurs, the catch block displays, error, division by zero is not allowed. The finally block then prints, execution of try-catch block finished. This demonstrates how exception handling can keep your program running smoothly even when unexpected errors happen. It's a simple yet powerful way to improve the reliability of your code. Zhash allows you to use multiple catch blocks to handle different types of exceptions. For example, you might catch a divide by zero exception, an index out of range exception, and a general exception, each with its own response. This flexibility lets you tailor your error handling to the specific needs of your application, ensuring that each type of error is managed appropriately. If you try to access an array element that doesn't exist, the catch index out of range exception block will handle it and display, array index is out of range. This shows how specific catch blocks can provide clear, targeted feedback for different error types, making your application easier to debug and use. Exception handling is crucial for preventing your program from crashing due to runtime errors. Always use specific exceptions and catch blocks for precise error management. The finally block, while optional, is highly recommended for cleanup tasks, and don't forget you can use throw to intentionally raise exceptions when invalid conditions are detected. These practices help you write safer, more reliable code. C. Exceptions are represented by classes. Most exception classes are derived from the system exception class. There are two main branches: system application exception, which supports exceptions generated by your application, and system exception, which is the base for all predefined system exceptions. Understanding these classes helps you create custom exceptions and handle built-in ones more effectively. System application exception class is intended for exceptions defined by programmers. If you create your own custom exceptions for specific application errors, they should derive from this class. This helps distinguish between system-level and application-level exceptions, making your error handling more organized and maintainable. System exception is the base class for all predefined system exceptions in C#. These include common errors like division by zero, null references, and out-of-range indexes. By understanding this hierarchy, you can better anticipate and handle the types of errors that might occur in your programs. Common exception classes derived from system. System exception includes system IO exception for IO errors, system index out of range exception for invalid array indexes, system null reference exception for null object references, and system divide by zero exception for division errors. Knowing these classes helps you write more targeted and effective error handling code. Wrap-up exception handling in C# is a powerful tool for building robust, user-friendly applications. Always use try, catch, finally, and throw appropriately. Handle specific exceptions for precise control and use finally for essential cleanup. By understanding exception classes and their hierarchy, you can manage errors effectively and keep your programs running smoothly. Thanks for watching and happy coding.